Alrighty, welcome to the Daily Space Weather Show, coming at you here finally. And yeah, let's get into it. Space weather for today, March 7th, 2024. So we've got some CMEs happening. We've got a little bit of a situation going on right here where we've got a rather large sunspot group which is starting to flare up, pointed right at the Earth. So you can see that right in the center of the solar disk right there. Here's a composite series of frames from SDO. That's 3 wavelengths. And keep in mind, folks, on this one, it shows 193 in actually blue, and it shows 335 in green. 335 is usually blue, and 193 is usually like a bronze color or like a purplish color. So, and it's also showing 94 in red. It's showing you down there at the bottom left. So those aren't the normal colors for those wavelengths. So, but that is a good composite there. And before we get into any of that, let's briefly take a look at what's going on stateside on planet Earth. First, the 304 angstroms wavelength. And yeah, so some CMEs, some filamentary activity going on, some possibility of major space weather, some major filaments on the Earth side of the disk, and so forth. We'll get to it. First, let's see what's going on Earth. We've got some erupting issues like Abiko, Suwanose, Jima, Ibu, Luitolo, Samaru, Merapi, Fernandina, located in the Galapagos Islands, by the way, creating some new real estate there. Also, Popocatépetl, Fuego, Nevado del Ruiz, Sangay, and Sabancaya. Next is our earthquake for the past 24 hours. There's the earthquake situation for the past 90 days first, courtesy of volcanodiscovery.com, as it states right on the screen. So next is our, this is the USGS map, just seeing what quakes have been happening here. A 5.1 struck Indonesia late last night. And then a long lull in quakes here until 8:20 this morning. Costa Rica had a 5.7. And then China had a 5.6. Not optimal for China to have earthquakes. Their buildings have a tendency to turn into a slurry of destruction. And then 3 minutes later, a 5.0 magnitude aftershock. So hopefully that's the largest event, and hopefully that 5.6 was not a foreshock. That said, Peru had a 5.0 at 1632. And those are the 5 and greater magnitude quakes. So talking back to space weather here, the 10.7 centimeter radio flux, which is a proportional data set to sunspot number, is now at, I have no idea what it's at. You know, I quote Einstein all the time, and one of the quotes is, never memorize something you can look up. Radio flux is 137 solar flux units. 137 solar flux units for the 10.7 centimeter radio flux, which is this black line. That's the past year. So, Space Weather Enthusiast dashboard here, forecasting some geomagnetic storm conditions. That is Friday night into Saturday. No, Saturday night into Sunday. Yeah, that's it. No, Friday night into Saturday. Yeah, tomorrow would be Friday. Yes, yes. So, there you go. Let us know if any space weather channels forecasted these CMEs. Could have sworn somebody might have seen those only hours after they occurred. Anyway, let us know in the comments if so. Moving right along to our geospace magnetosphere movies. They depict magnetohydrodynamic pressure based on a lot of variables. And guess what? There's good news, folks. The likelihood of geomagnetic storms has gone up. Why is that? Because of the Russell-McFerrin effect. That is when, well, let's go back to this one. That is when electrons are accelerated in the outer Van Allen belt. So the outer reaches of that of this right here, electrons are accelerated in those areas, and it has to do with the angle of attack of the solar wind versus Earth's magnetosphere. So that accelerates electrons in the outer Van Allen belt, and that creates a higher likelihood of sufficient induction into the Earth system in order to induce geomagnetic storm conditions. So the Russell-McFerrin effect is what that's called, and it is most prevalent around the equinoxes. I think March is actually, is it March? I think March is actually the most geomagnetically active month in recorded history, but it could be the same at either equinox, or it could be a little bit different, not exactly sure. This map depicts ground magnetic perturbations. That might be a question for our Ask a Particle Physicist segment someday, but not this week. This week's Ask a Particle Physicist segment is already completed. We'll include it in tomorrow's daily space weather video. So that's the past 4 hours of Earth's magnetic moment from the ground. KP index is at 3.33. 3.33. Uh-oh, folks, repeating numbers. Time to get in your bunkers. Repeating numbers equals get in your bunkers. 3.33 is the planetary K index. Oh, my God. Oh, noes. 3.33. Dear God. I would remind our viewers that numbers are arbitrary, so numbers aren't spooky in any way. They're designed to describe reality, not to be a spooky talisman of spookiness. Numbers aren't magic, folks, last I checked. But, I don't know. Call me a skeptic. I'll be your Scully on your... Just kidding. All right, so, yes. So, real-time solar wind is next, and what do we got? About a 3 proton per cubic centimeter solar wind there at ACE, and at 421 kilometers per second. Discover. Showing, I don't know what it's showing because I don't have it queued up. How do you like them apples? We'll remedy that. There we go. There's the Discover. And very similar there. Only 5 protons per cubic centimeter. It looked like we were going to get into geomagnetic storm conditions, but things have subsided. So we're going to see the KP index drop at the next update, which is coming soon. So KP index here to drop below 3.33. That is the situation. So GOES magnetometers here are looking pretty smooth. That's the past 3 days. Let's show the 7-day forecast so you can see the last little geomagnetic storm there. Some little perturbations happening. That's the kind of thing you can expect to see associated with the KP6. NOAA's forecast does not include a KP6, more like a KP5. And I would tend to agree it's going to be pretty mild. Most of the plasma will miss Earth on that next CME impact. Pretty sure that's not the coronal hole high-speed stream, but there is one of those also. So we could have co-interactive regions where the totally different features of the coronal hole high-speed stream along with the CME, they can interact with each other in ways that I won't get into because this is supposed to be a video that's rather concise. Anyway, that's the past 7 days for the GOES magnetometers. Here are our top view plane field plot data. And is Earth in a North Pole current sheet solidly now? We should be, and indeed Earth is. So there you can see that. The last frame there, like we said yesterday's video was just when Earth was snapping across. So that data, 1 hour and 40 minutes old. Keep in mind the magnetic environment can change with absolutely no warning. Next is that's our line of sight field plot, and you can expect to see North Pole oriented coronal holes rotating in here. And so you'll see North Pole-oriented polar fields associated with those. The B field depicted in blue, photosphere magnetism in grayscale. And here's our coronal hole line-of-sight field plot. That is, again, 1 hour and 40 minutes old. North Pole coronal holes rotating in. Here come coronal holes in our ever-popular 211 angstroms wavelength. There you go. There's 211. And let's move on to sunspots. Sunspots. Wherefore art thou sunspots? Well, because of magnetic fields in the photosphere. Or something. Or maybe they caused them. Anyway, I won't get into the chicken or the egg over it. But in any case, there you go. There's a sunspot number. It's been pretty level here for the past about 4 days. And let us know in the comments what you think. As today I'm not forecasting sunspots. I don't see anything sufficient to allow a forecast since extraordinary claims require extraordinary evidence. Do you think sunspot number is going to go up next or down since it's been hovering right on the average line? See, that's the current average. Do you think we're going to see a lower or higher sunspot number on tomorrow's daily space weather video? Let us know in the comments. We challenge you. Do you dare to forecast the sunspot number? Will you be forecasting your own doom? No, you definitely won't, because it's sunspots, and sunspots aren't going to doom you. So anyway, here's our flare probability monitor and scoreboard, and the most likely place for a large flare, at least a relevant one, would be sunspot 3599. So that's actually named 2 sunspot groups there. 3599 looks a little bit better, a little more likely to produce a large flare, and it is brighter on the GOES 16 SUVI also. So moving on to sunspots. Gotta have that, and oh my god, what has happened here? Jeez, oh whiz. I apologize for that. This temporary aside was brought to you by the Smash News Network, least busted name in news. So we do have a little bit of growth down here, but nothing major. That is a significant sunspot group, as it is at least a beta class sunspot group. Next, we'll cover energetic particles and solar flares. So there's a GOES proton flux, and not too exciting there. As far as the X-ray flux, though, seeing some more interesting activity here. So a series of flares, and let's check and see where they came from. This latest one probably won't be on the video yet, but the latest one was a C3.5. Not just a modest flare, I mean no M-class events. So anyway, let's take a look at those. Doggone, we got to look at sunspots yet. Oh, we've got more sunspot stuff here. Let's go back to sunspots. Allow me to return to sunspots. That would be good. All right, so we'll also show the colorized magnetogram. There's that for today. That's March 7th. Here is the colorized magnetogram plus 171 angstroms. A little bit jerky there. A problem with the synchronization, I think, is what that is. And here's the 94 angstroms wavelength, which is excellent at showing solar flares. It has a higher temporal resolution, along with 131 angstroms, than the other wavelengths. 131 and 94 are specifically, in order to view solar flares, keep in mind it's part of the extreme ultraviolet spectrum, so technically you're not seeing flares, as those are not X-ray spectra. It's extreme ultraviolet spectra. But that's what's going on, and those flares have come out of that sunspot right in the Earth-facing portion of the solar disk. Sweet. So do we have any CMEs or anything, though? That's the real question. So let's take a look and see what we find. So I don't think so, but let's check. First, a star chart. We'd like to show people what's going on overhead on the daily space weather content, so there it is. That's what's happening over our head. You've got Mercury setting along with Jupiter. Just press the Now button, and it'll advance your sky to where we currently are. You'll even be able to see where to find Deneb if you're viewing the early dusk skies there over Lehigh Valley, Pennsylvania. Next, the solar system forecast. Where are things now? Well, it's lonely on this side of the solar system. And let's advance this 1 week as Mercury comes around to give Earth some company. That's a fast planet. So there you go. That's where things will be in a week. We'll have a crescent waxing moon by then, as new moon is about 3 days out. Next, we're going to show you a nebula here with a monolith in the center of it. Are you ready for this? Are you ready to be freaked out, folks? Have the aliens that are in 2001 A Space Odyssey, are they now a real thing? Well, if not, why the heck do we have a nebula with a monolith in the middle of it? What is up with that? Oh my god. Is that a monolith creating a solar system? Is that a galactic torch? Is there a galactic torch burning? Well, it's not what's happening at all. It's just the Crew 8 nebula. It's from the James Webb Space Telescope there. It's not the James Webb Space Telescope, that is. It's the SpaceX Crew 8 mission. So it's a bunch of exhaust plumes from that, and that's what that is. It's not full of stars, it's not a monolith, and it's not aliens. It's just humans and a bunch of plasma in the mesosphere, perhaps? Some layer of the atmosphere. I don't know. Next, coronal mass ejections. That's what's been going on today. And we've seen some motions, but we don't see any, well, I don't want to count my chickens before they're hatched. So, yeah, you've got, what the hell did I do here? There we are. We're going to bring the C3 back so it's somewhat synced with the C2. And they're not synced at all. All right. Let's skip that entirely and show stereo A and its difference imagery. And we're going to show our own custom coronagraphs. Man, oh man, sup with that. Sup with that, folks. Yeah, missing 10 hours of data there on the raw coronagraph. Missing even more data on difference imagery, so that's completely unhelpful. And let's move on to our custom images. Since we did take some, I'm glad I did. If I would have tried to skip that today, that would have been a failure. So there are our custom coronagraphs. Did we get all the data there? Yep, it looks like it's all there. And if there are any new CMEs headed this way, oh, there might be a pretty strong one there. All right. Is that another earthly directed event? Let's check. Yeah, I think it is. It's right out of the center of the solar disk. So there's another one expected to arrive sometime late in the day on the 10th. Late in the day on March 10th. Maybe midday. But sometime like midday or late in the day on March 10th. CME headed this way once again, folks. So now that leaves us an additional, I think there are 2 still on the way. See our previous Daily Space Weather videos to learn more about that, because keep in mind, like the last 2 days are still going to be relevant, folks. So anyway, yeah, more earthly directed ejecta. And we're going to get the filaments here in just a moment. So, but first let's cut to our coronagraphs again, because they are pretty freaking sweet. Pretty sweet indeed. So here you'll see a big eruption right here out of the center of the disk, and you'll see that represented on the coronagraph. So a large portion of that is likely to be in the earthly zone. Expected to arrive on March 10th. Here's a little better view of that. You see massive levels of limb darkening, and what we're showing there is the SDO 304 angstroms wavelength, so ionized helium, as well as 193 angstrom 60-minute running difference imagery. That's ionized iron. So that's good at showing all the contrast, and it gives you a little better idea of the way the plasma is moving about. We try to sort of keep it limited to the number of different wavelengths we use so that it's not completely a cluster. So, but that's another Earth-directed CME there. So perfect example of it. Here's an even closer view for your viewing pleasure. Not too bad. Not too bad at all. So a couple more events on the way here. It looks like the sun's stopping. It's not being such a plasma miser, folks. So, and just in time for the Russell-McFerrin effect that I mentioned earlier. Anyway, on to plasma filaments. So here's Cerro Tololo's ground-based observatory, and lots of dense filaments there. You can see those absorption features. They appear dark on the solar disk, and you'll see them appearing bright when they hang off the edge of the limb when they become a prominence. So they're dark when they're absorption features. They're bright when they're not obscuring part of the sun. Prominences and filaments there. They are the same feature. So there we've got the Mimi filament, and check it out. That one that's rising down there in the southeast is certainly name-worthy. If you'd like to name filaments, do it on Twitter, x.com/smashomash. Name them after living people, your friends, your foes, or perhaps even yourself. A little bit of a CME going on there right now from the GOES 16. That will not be earthly directed. We've also got a crown prominence up there at the North Polar region, so plenty of stuff going on despite relatively low solar activity. Here come bonus features, starting with charging hazards for satellites. Shoo. It's been a long day. So there is the satellite charging hazard map, and we've got some significant surface charging hazards there showing up in the Middle East. So that's going to be low energy electrons building up outside of spacecraft. That can cause some communications failures. So we may see that in some of tonight's satellite imagery. We'll see what happens. I sort of doubt it because of their location and the location of the data we'll be using, but we'll see what happens in the meteorology segment. The GOES electron flux here is still kind of on the low side. Electron shortage continues, folks. Might be bunker worthy. Look at, we've had an electron shortage since December. So if you think low electron counts are very spooky, then it could be bunker time. They aren't spooky in any way. Next, the GOES electron forecast here goes the relativistic electron forecast by NOAA. That's the NOAA is guessing the electron flux, and they were off by a little bit on this latest one, and it had to do with CME impacts arriving. Ones that were forecasted, that kind of CME impact. Anyway, let's show the ionosphere next. This is the layer where it's measured, the F layer. It's at about 300 kilometers of altitude, and there it is. It does puff up in the daytime and things, but we won't get into that. That should be definitely for a Ask a Particle Physicist segment. There's the vibrational frequency of the ionosphere. We've got quite a lot of high-frequency anomalies there indicating no real major space weather have been showing up for the past 24 hours. Just minor stuff. There's the anomalygram. It depicts anomaly in megahertz from the 30-day median. Next, the global ionosphere nowcast. Total electron content on the left. Maximum usable radio frequency on the right. And that's about the end of the space weather coverage for the day, folks. By the way, if you want to get a chrome hat of your own, head to amazon.com/shop/smashomash. Head to the Spacewear collection, and there is all kinds of stuff that you can pick up in there. Anyway, we'll close out space weather with the latest intensitygram and colorized magnetogram. So a brief look at this sunspot, the one that's been flaring, and then we'll move on to meteorology. There it is. It is Beta Gamma Delta class. And here comes our meteorology segment. We're starting out with Earth's winds. Surface winds are first, starting with the east. Yeah, we go east to west, folks, because, we rise with the sun on the channel. So, yeah, there you go. There's the eastern world's surface wind scenario. There's the jet stream scenario, jet streams of the central world shown there. Surface winds shown here. Surface winds of the western world shown here, and jet streams shown there. Next, the satellite imagery over the Americas, and notice how straight that line is getting the day-night terminator and night-day terminator, and we are seeing some interference on that satellite right in there. That's from electrons building up on the outside of the satellite. So isn't it great when the data correlates with reality? It's just awesome. So there you go. That's our satellite imagery. And did you know that windy.com has a fantastic mobile app as well? I figured I would show this just to show you. It's great for beginners, like if you're not really hardcore weather nerd. The Windy app is really convenient. You know, the first things it shows on the list are weather radar, and then satellite, and then wind gusts. But there's all kinds of complex stuff on here, like the CAPE index, which is the potential energy. You can look at sulfur dioxide, so if you want to track volcanic activity, you can see that on there. Carbon monoxide to cover fires, pressure maps, extreme forecast, drought monitoring. Like, there's all kinds of stuff on there. And this is just in the North Pacific. I just zoomed in on that spot to show you that crazy low pressure that once again is pumping a bunch of moisture into the western U.S. So there it is again, a fantastic and it's an integrated satellite map too. So if you go to the night side of the planet, it will use something like the shortwave radiation satellite. It will still show you the clouds and fog. It just automatically switches back and forth. So if you look at the day-night terminator, it's pretty awesome. You know, you'll be able to see it switching to the visible satellite. I think I just killed it. Oh, there we go. So, fantastic imagery there. Highly recommend the windy.com mobile app. It's free. I'm sure it contains spyware. Every app does. And you have a second device if it's that big of a deal. Like, who cares? You're that spooked. Oh no, it's gonna detect a thing. I'm not very spooked of it. It's anyway. Here's our weather.gov map, and we've got a bunch of like winter storm warnings and some flood warnings around the Gulf states, which we talked about yesterday. We'll talk about it again today. People that wait for the last second to find out about the weather are less well prepared, let's just say. So here's pressure and precipitation. Some heavy precipitation coming to the Pacific Northwest and the Gulf states. 72-hour positive accumulated snow depth change forecast is next. And a bit of snow coming. That's where it's coming to. The heaviest will be in eastern Canada. A little bit of blanketing of 8 inches up there. It's been a variable winter in eastern Canada. Wild stuff. Wild stuff. Mostly very warm. Also, our accumulated precipitation forecast in inches. And you've got 4 inches of rain coming to parts of Alabama, Georgia, and South Carolina, especially also North Carolina and some other spots. Well, see the map for details. Missouri, Washington, some really, really heavy rain is on the way. Next temperature anomaly forecast in degrees Celsius. A picture says 1,000 words. I'll say 0. Lightning. Lots of lightning in South America there, folks. Let's take a look at a real-time lightning map. We've got terrestrial strikes in the U.S. Who's got thunder rolling in? Abilene. Hey, Abilene. There's thunder rolling in. Yes, that is a prediction of thunder. You can use lightningmaps.org. It's just a web page. That one doesn't even require an app. It's just blitzortung.org's lightningmaps.org page and lightningmaps.org. Highly recommended. Yeah, it's a real-time lightning map. It's freaking awesome. I remember the first time I used it. I used it one time to figure out if lightning was going to strike the parking lot that I was in. Then I realized the thunder I was hearing was like 6 miles away, and I entered the grocery store. Fantastic. Don't get struck by lightning, folks. It'll likely not prove survivable. So, here is our Doppler map. We're closing out with the lower 48. We'll show Doppler. We'll show satellite. Satellite. As spring arrives, by next week at this time, it'll be broad daylight yet by this point in time. And there's the water vapor map, and here's the recap. vertical motion in the air column depicted by that visible satellite from like 23,500 miles of altitude. And there is the water vapor map. Same altitude, different bandwidth, different wavelength. And here's me closing out. See you next time. I've been your host, Dan, a.k.a. Smasher Mash, signing off. May that solar wind be at your back. Whoa.